ToxPathGuard is a molecular safety audit tool. You give it a SMILES string, that's the standard text representation of a chemical structure, and it evaluates the compound across 3 independent biological stress pathways, explains what is driving the risk score, and tells you how confident it is in the result. The whole system runs offline with no cloud dependencies. Let me show you. Ethanol. Common alcohol, well-studied, no toxicity concern at this level. The system clears it across all 3 pathways. You can see Agent 1 at 2%, Agent 2 at 16%, Agent 3 at 9%, all below the safety thresholds. No structural toxicophores detected. The domain check shows this molecule is at the edge of training space, which the system flags honestly, but the model scores give us a clean, cleared verdict. Now, the opposite extreme. Benzoaperine is a well-known polycyclic aromatic hydrocarbon, one of the most studied genotoxic carcinogens. All 3 agents fire, 96%, 88%, 92%. The structural alert module independently detects a PAH scaffold. Because the model and the chemistry agree, the system labels this a confirmed toxicophore, which is a stronger signal than either the model or the alert would give you on its own. High confidence in domain, high risk. The SHAP panel tells us exactly which features drove this score. For benzoapyrene, the genotoxicity agent is being driven mainly by ring count, 5 rings, and by its high log P, which reflects how lipophilic the molecule is. Molecules that accumulate in membranes and contain large fused ring systems are a textbook genotoxic profile. The model hasn't just memorized a pattern, it has learnt a chemically coherent relationship. Paracetamol is interesting because it shows a real tension. The aromatic amine structural alert fires. There is a nitrogen on an aromatic ring, and that is a known genotoxic pattern class. But the model scores are moderate, not extreme. 26%, 41%, 37%. The system gives a caution verdict and labels this confirmed toxicophore under the sensitivity-oriented thresholds. If you switch to training thresholds, it drops to alerted but model score low. The system tells you that difference explicitly. That's exactly the kind of nuance a researcher needs to decide whether to flag this compound for additional testing. One thing that kills a hackathon demo is a crash. We ran a 15-molecule test suite that includes invalid strings, empty inputs, out-of-domain macrocycles, and very large molecules. 0 crashes across the board. Invalid input is caught cleanly before it touches the models. ToxPathGuard doesn't just predict toxicity. It identifies which biological stress pathway is most concerning, explains which chemical features are responsible, checks whether the molecule is chemically similar to anything the model was trained on, and tells you how confident it is in the result. It runs entirely offline on a laptop. The full pipeline, from dataset audit to trained models to this dashboard, was built in phases with reproducible, versioned code. We think that combination of prediction, explanation, and honest uncertainty communication is what a useful computational screening tool should look like.